Good morning or good afternoon. This is Marjorie Imprine, and I'm coming to you with a math problem from the BJU Press Algebra 2 3rd edition book. And it is from Lesson 8, applying principles to solve logarithmic and natural log equations. And this was a question that we had in class, after class today, and I didn't have time to look over it and answer it and give a good answer, but I've come home and worked the problem. So here we go. The question was, the book shows two different methods. If you look in 8.8 at example 3 or 8.7 at example 2, it's the same kind of problem, the same properties applied, but they solve it two different ways. And the question was posed, why do they solve it one way in one place and another way in another place? And the short answer for that is that it doesn't matter, okay? And that you can solve it either way if you want, okay? And I will prove that right now. Okay, so it says right here, the problem is solve 6 to the 2x minus 1 equals 3, okay? So the first method, we know from the exponential property of logarithms, we're going to use natural logs or logarithms. They have the same properties to solve this. We know that this exponent, 2x minus 1, I'm going to zoom in here, 2x minus 1 needs to be brought here to the front, and then a natural log applied here to the 6, okay? And whatever you do to one side of the equation, you have to apply the natural log to this other side as well. Okay, so this method is a distribution method, okay? So we're going to distribute 2x minus 1 across the natural log of 6. And what you're going to end up with is 2x, natural log of 6, right? 2x, natural log of 6, minus 1 natural log of 6 equals natural log of 3. 2x, natural log of 6, now we're going to move this to this side of the equation, equals natural log of 3 plus natural log of 6. It became a plus when it moved to this side of the equation. 2x natural log of 6 now is equal to natural log of 18, okay? Why? We're going to use the product property of logarithms. So we know that natural log of 3 plus natural log of 6 is natural log of 3 times 6, even though there's a plus sign here. That's the product property, and it's going to give us an 18. Okay, so now what are we going to do? We're going to divide both sides by natural log of 6 to isolate our x. So 2x natural log of 18 over natural log of 6, okay? And then x equals natural log of 18 over natural log of 6, and we multiply by 1/2 to get rid of the 2, and we have to do the same thing on this side, right? So we end up with x equals natural log of 18 over 2 natural log of 6. If you put that in your calculator, you're going to get 0.806, okay? All right. So now what's the other method, okay? The other method is to do it without distributing, all right? So we have the same problem here. And what we're going to do, we end up with 2x. We did this part right here where we brought the exponent down to the front here, all right? And you have 2x minus 1 natural log of 6 equals natural log of 3, okay? Now we are not going to distribute, all right? We're just going to divide both sides by natural log of 6. So 2x minus 1 equals natural log of 3 over natural log of 6. Okay, so now you have 2. Now we're going to further simplify. We're getting rid of our everything away from our x. So 2x equals natural log of 3 over natural log of 6 plus 1. We just brought our minus 1 over here and it became a plus 1. Okay, now we want to further isolate the x. Okay, we're going to say 2x equals, and I just put this in the calculator and end up being 1.613. X equals 0.806 when you divide both sides by 2. I made a mistake in the class saying that it does matter whether you distribute or you don't distribute. It actually does not matter. Okay? All right. I hope this is helpful to my students, and I'll see you next week. Thanks. Bye-bye.